This lesson has been developed in the framework of SCILED project. Module 3, Footwear Design Engineering, Unit 1, CAD, CAM, CAE Systems for supporting integrated footwear design.
Lesson 1.2. Computer-aided tools for material selection in the footwear industry.
Introduction. Material database. Material selection software. Other tools.
Introduction.
In the design world, the material, shape, and performance of an artifact is often closely connected and influence the characteristics of an object. The same goes for a shoe. For example, the selection of a technical fabric rather than another in a mountain shoe can change the resistance of the upper part, modifying its lifespan. Because of this, it is important to know both the properties and the behavior of the materials that will be used inside a shoe. This will lead the designer or the developer to a conscious choice during the selection phase. Nowadays, in addition to the databases for common industrial materials, there are also various material selection software. Each one contains the basic and necessary information for a designer to choose a material that meets the requests about performances and characteristics. Most of them are free to use, so anyone with good IT skills can access these tools. The most advanced software also offers manuals and online tutorials that facilitate the materials review and the learning process of fundamentals functions. The use of these tools implies also other benefits, like a more targeted choice, thanks to the possibility of comparing the various materials according to the physical properties to be satisfied, and consequently, speeding up the choice process. There are two main types of tools: material database, material selection software.
The former is about big databases that contain data that can be easily found by a user or by a computer program. The latter, the material selection software, allows for more advanced evaluation and query, also helping with data visualization.
The use of these types of tools allows obtaining data concerning physical properties referred to specific performance of a shoe in a very simple way. These data can be inserted within tools that allow the simulation and calculation of phenomena related to the performance and comfort of the entire footwear. By doing these simulations, it is possible for a designer and a company to accelerate the design phase, reducing prototypes, and have a more engineering and scientific approach to the development of a shoe.
Material database.
As mentioned before, the material databases are large libraries containing sheets with precise and detailed information regarding the materials. The characteristics of these archives can be very different. They can be free or accessible by subscription, generic or specific to certain types of materials, commercial or academic. Each of these features add a level of complexity to the software. Some of the easiest and free software to access that can be mentioned is makeitfrom.com, but also Match. On the other side, MatWeb is one of the most complete service. With over 135,000 material sheets, this platform covers the most general categories of materials, such as metals, ceramics, polymers, composite materials, natural materials, linear materials, thresholds, and other forms. Inside the website, it is possible to download the datasheets of each material and to consult physical, chemical, commercial, and other data. Besides, databases such as MatWeb give to the user the possibility to export and download data in special format. So, they are ready to use inside the most common CAD, CAM, CAE software, avoiding the user to replicate the properties of the material within it.
Material selection software.
Compared to the databases, material selection software offers more advanced operations regarding the research function, the verification and comparison of the data. Moreover, it also provides a visual representation of the information. The most used materials in the footwear sector, such as
wood, aluminum, plastic, covers and adhesives,
are usually already inside the generic commercial software, since these ones covers a wide range of industrial materials. From this kind of software, it is thus possible to understand part of the future characteristics of a shoe, as the software provides information regarding the physical and chemical properties of the materials. As previously mentioned, the most advanced software allows a comparison and a graphical representation of the information through diagrams. One of the most common is the Ashby plots, which is named after the engineer Michael Ashby of the Cambridge University. This type of diagram compares two or more material properties, or different types of materials, using a scatter diagram. The comparable properties are different and range from very technical ones such as Young's modulus, to commercial characteristics, like the price. A graphic visualization of this information allows the designer to have a quick and intuitive comparison, and to make a more conscious choice. This happens especially when it is necessary to satisfy specific requests, for example the lightness of the sole at a given price.
Material selection software.
One of the most generic and engineering material selection software is the Granda CES Selector. Released in 2012, this software is one of the most complete, accurate, and it is used especially in the product design field. It is really easy to use and intuitive, but in its website is also possible to find a large amount of resources such as videos and webinars that teach how to use the software.
Other tools.
There have been developed lots of computer-aided material selection software. Some of them are not commercial. In fact, there are some software and methods developed within universities or international research programs which have not been commercialized. This is the case of the LibTeX database developed by 3 researchers from the Liberec Technical University, in the Czech Republic. This database allows the assessment of fabric performances starting from parameters of threads, fibers and textures. In particular, materials such as fabrics, that have linear fiber structures whose properties depend on factors like the direction of the fibers, require specific and complex calculations to determine their performances. Despite its cleverness, this software has some limitations. Many fabrics are subsequently treated with resins and special finishes. Those are parameters that the program does not take into consideration. Because of this, LibTeX is more suitable for simpler fabrics. Furthermore, the calculation of linear tension is not sufficient for a shoe, because it receives complex stress from all directions. In an attempt to solve this problem, another database of leather fabrics and specific materials for footwear was developed as part of the EnviroTeX design project. This supports the interactive matrix, i.e. a performance evaluation model based on a neural network. Nowadays, safety and sustainability are important issues that also footwear companies must take into account. This regarding not only their product but the entire production chain. Sustainability is still a matter of debate as it does not have a unique and scientific method for being calculated and measured. Despite this, many generic applications concerning materials sustainability have been created. The number drops dramatically when the field narrows to shoe companies. The best known are
Shoe Law Tool on legal requirements for footwear products and processes, ShoeBat Tool on best available techniques for footwear production, CO2 Shoe Estimator for carbon footprint, EnviroTeX Design Platform, which addresses both process and product aspects, HIG Index Tools by the American Sustainability Apparel Coalition, Islam and Khan, 2014, which was discussed in a different lesson and which was supported by American associations.